Hi guys, let's solve the problem longest repeating character replacement. So in this problem, we've been given a string s and we've been given an integer k, and essentially we are allowed to change any character to any character in the string. You can choose any character of the string and change it to any other character, and you can perform this operation k times. So I can change an a into b or b into a, or however that needs to be done. But the question is, return the length of the longest substring containing the same letter you can get after performing the above operations. So at the end of the day, we have to have a contiguous string, a substring where all the characters are the same. And we have to find the longest such substring. So that is the question. In this particular instance, you could replace A's with B's or B's with A's, because you can do two replacement. So either way, we'll get a 4. In this question, we start here. So this is, we don't need to change on the first instance because this is the same character no matter what. On the second one, it's the same repetition, so we don't need to change, same character length 2. And on the third one, we see there are two A's, one B's. And so what will we change? We'll change B because that's the less frequent character. If we change A's, we'll have to make two changes. If we change B, we can get away with changing one character. So we, to maximize the length of the string, we have to somehow do the minimum operations needed. So we pick the least frequent one, B. All right, that's good. So we can get a length of 3 by making one operation. Let's go further. Look onto this string. So we've got 3 A's, 1 B. So again, we can make one change and B into A, and that would give us a length of 4. So that's good. Let's keep moving forward. And now we've got 3 A's and 2 B's. So the question is can this be a valid result? And it cannot be a valid result because we can only make one change, but but by making one change, we cannot have a substring that is got all the characters are the same. That is not possible. So again, we'll have to change B's if we could, but just let's take a look at that. This is length 5. This is length 5, and the number of operations that we need to do to get to get to get a string that has got the same characters. At least we have to make two changes. So what are we looking at? We are saying that the length of the string is 5, and let's, from this 5, let's subtract the most frequent element, which is A. So A is 3 times. So that is how we get 2, that we need at least 2 replacements. Now the obvious question is, why are we subtracting the most frequent character rather than just counting B's? Well, we're doing that because there is no guarantee that there are only 2 characters in the string. You could have B's and C's and D's. So rather than counting all the other unique characters which are not the most frequent, what we can do is we can just capture that number by subtracting the most frequent character from the length of the string. So in this case, again, that would be 5 characters overall. The most frequent is A, which is 3 characters. So we get the number 2. Now, how do we know whether our string can be valid or not? Well, that number, the difference should be less than or equal to k, because if it's more than k, that means that we cannot do anything. Even if we start changing, making k operations, we'll be left with something that is not the same as the rest. So essentially, in this particular case, because we are left with 5 minus 3 is 2, which is greater than k, what we'll have to do is we'll have to start moving the substring from the left on up here, because we want to be able to scan the entire list. So we cannot just sit on the first and on the first index, zeroth index, and we cannot just look at all the strings starting from here. We'll have to move forward here. So we'll say, okay, let's drop the last one, the first one out, and let's just focus on these 4 now. Again, if we focus on these 4, what do we get? We get a length of 4, and from the length of 4, we subtract the most frequent, which is 2 in this case. So we are left with 2. So again, 2 is greater than the number of operations we can do. So again, we'll have to drop the first index from here. So we'll be left with a length of 3. So this is BAB. In this particular instance, we have 3 characters, and the most repeated character is B, which is of length 2. So we say 3 minus 2, which is 1. And yes, we can make one change. So we can basically change an A into B and get a length of 3. So this works fine. So this is of length 3. But notice how we already had a length 4. But that is fine. We already saved it in our global maximum length so obtained, but here we are computing the local length. So we'll continue moving forward just in case we find any other length that is more than 4. But if not, then 4 would be the answer. So okay, this is a valid string. So when we've got a valid string, what do we do? We move the right pointer further. So now we've got a length of 4 and the most frequent element is B. So we subtract 3 from 4 and we get an answer 1, which is right, which is A. So we can replace A. So that means that a length of 4 can be obtained correctly in this case as the answer, because we could have 4 B's. Okay, so let's move the right pointer further. Now we've got a length of 5 here. Length of 5, the most frequent character is B, which is there are 3 B's here. So 5 minus 3 is 2, which we see there are 2 A's, similar A's. Although it could have been an A and a C, there is no guarantee it would have been A's. But in either case, we are fine because we just subtracted the most frequent character B. So 5 minus 3, that is 2. So we have to make two changes. Well, we only have K is equal to 1, so we cannot make those two changes. So we'll have to shed this B and just come on to these four elements or these four characters, and again we'll do the length is 4 minus most frequent character is 2, so we have to make two operations. Again, it's not viable, so we move the left pointer further. In this case, we get a 3, and 3 minus 2 is 1, so we can make that change, so the length is 3. And then we try to move the right pointer further, and we already hit the end of it, so there's nothing further. So we basically got two lengths of two four lengths. So either this could be changed into an A, or this could have been changed into a B. So that would have been four B's. And if you look at the answer, it says replace the 1A in the middle with B to form. So this is the second thing that we were looking at. The substring has the longest repeating characters, which is 4. There may be other ways to achieve this. And yes, there was one other way in which we changed this B into an A. So I guess we've discussed this quite enough. We can code it. Before we code it, what is going on here is we are just traversing through the entire list here through the entire string. So that means that it is an O of n solution. And in addition to just traversing the string, what we are also doing is we are having to compute the maximum frequency of the characters in the string we are looking. For example, here we were looking, well, the maximum frequency was A, was for A. So how do we do that? We can maintain a hash map where we count the number of occurrences of each character in that substring, and then we can basically take the maximum frequency in that hash map, which can be obtained uh, uh, by the hash map dot values function. But that will have to basically scan the hash map itself, which can be of length n in the worst case. But the thing to note is the the length of the hash map is actually 26, because the keys, there are only 26 different characters that are available in the string. So even though because the length is 26, it's basically a constant lookup. But you'll get a runtime complexity of the length of the string, which is n into 26. All right, so that is that. Let's code this up so we can have a hash map, call it count, because this is going to count the number of characters in the substring. We have the global result variable set here. Let's set the left pointer in the beginning to start, and then for r in. Now, there are several things that can come to mind. Can we just not use the value directly rather than using the index? So in this particular, in all questions, what we have to think is we can accomplish this in multiple ways. We can either say for r in s rather than saying range in length of s. So in that case, we would have been picking the character straight up. And one can think, why aren't we doing that? And that is doable, but in here we also have to keep computing the length. So if you have to keep computing the length, then what do we need? We need the index, because we'll ultimately end up saying r minus l plus 1. Like if the right pointer is here, 0, 1, 2, and the left pointer is here, what do we want? We want 2 minus 0 plus 1, which is the length here. So we ultimately do need the index. We also need the character itself, because that's what we'll be putting in the hash map. So either you can do this and then use the function s of r, uh, with this computation to add values to the hash map, or you can do an enumerate function, but this one's easy as well. So whatever one feels comfortable with. But let's build the hash map here. So so this is the count. Count was the hash map, and what would we say? We have to add the rightmost index, the character on the rightmost index. We have to add that. So we'll say 1 plus, and then here we'll say count dot get s of r comma 0. Now, the reason why we are not doing it as count of s of r here is because if that character does not exist in the hash map in the first place, this entity is going to give an error, is going to give a key error. So here this function dot get basically lets us get away from that thing. So here, if s of r does not exist, then it will be a 0 in the first instance. So we'll say 1 plus 0 is equal to 1, and then that would be initiated. So we added the characters to the hash map. So this is happening one at a time. So first we added the first one. Okay, that's good. Now what are we doing? After we added the first character, we have to check. Well, what do we have to check? We have to check the length. What is the length? R minus L plus 1. So so initially R uh, this R would be a 0 because we've not incremented r really, so we are on the first index, so r is 0 and l is 0, and so 0 minus 0 plus 1, so this is the length. But then r will keep moving forward. R will become 1, so and l will remain 0, so that would become 1 minus 0 plus 1, so that would become 2. So this will continue to give us the length of the substring. And then what do we have to subtract? We have to subtract the maximum most frequent the most frequent character, so as to obtain how many characters can we replace. So we'll say max of count dot values, because we are storing the count here, count of the characters here. So that is what we have to replace, and we have to make sure that this is greater than k. And so this could be this operation could be required multiple times, not just one time. So we'll use a while here instead of an if, because while this is uh, this should be less than k. But the thing is, because if this is less than k, then we the string so obtained would be valid. But if this is greater than k, then what will we have to do? We'll have to start removing from the left side. So how do we remove from the left side? We'll say count of, because we'll have to first remove it from the hash map. Because hash map is just representing the the frequency of the characters in the substring that we have. So let's decrement that character on the left side, and then we'll have to increment the left pointer itself, right? All right. So this is all that we were speaking about. That when we move forward, we have to leave the left ones out. Otherwise, we'll not be able to move the substring forward. And we have to scan the entire list to be able to see where the maximum lies. So okay, this is that, and and once it is valid, meaning like while this is happening, while this is greater than k, this operation will go on until this thing, the difference of this thing is equal to k, right? And what do we do at that time? So we say we update the global variable, which would be max of result, what it was already, and this would be r minus l plus 1, which is the length of the string, and then we can return the result. So yeah, this is what it is. As we discussed, the complexity of this solution is O of 26n. N is the length of the string S, and 26 is because we are computing this on a hash map where the keys could be as much as 26. So it might have to scan through the entire hash map every time to be able to find the maximum value. There is an optimization here uh, that is a little complex, and I think is not probably needed. But what one can do is one can have a running counter. Well, this is fine.